If we were just using the same stuff that we did yesterday, why would this immediately be a challenge? Yeah. Right. Because there's a cosine and a sine, and we had some mixtures yesterday, but I think the mixture that we had yesterday, like this last one, with a mixture of tangents and sines, was factorable. This is a mixture of stuff, and it's not factorable. So, thoughts? Guesses, things worth trying. Andrew? You can only tee it up if it's something times something else equaling 0. Joey? Correct. This was going to be your hint. Was that creepy? Here's your hint. Use ideas from the reference sheet. So, cosine squared is an easy one. This isn't technically on your reference sheet, but it's some of the ideas you have to know. Can be replaced with, well, since sine squared plus cosine squared equals 1, I can replace cosine squared with 1 minus sine squared. And then when I simplify this, 2 minus 2 sine squared x plus 3 sine x, and then rewrite it so that it's in the proper format. So the sine squared x term first, the sine x second, and the constant last. And then I hate negative leading coefficients, so I would just divide both sides by -1. That's just me. You don't have to do that step. Now it's factorable, because now we have that traditional trinomial look. Does that make sense? Can I stop there? I think it'll be the same from that point forward. Okay, if I jump to number 8, mixture of cosines and sines, not factorable. How's our reference sheet substitution ideas going to be helpful? Do you see anything, Morgan? Double angle, and it's the cosine of 2x, so we have a choice. Remember, by the way, on your test on Thursday, these are going to be blank. The reference sheet I hand you, there's going to be 4 blanks here. You have to fill in yourself. Those are the ones. I don't know if you remember this, so I wrote it right there. That's already on yours, isn't it? Yours says memorize. Yeah, remember that those aren't going to be given to you. You probably want to get your reference sheet from the test and immediately write those down. But which one, Morgan, would you try using? I think that's a good idea. 1 minus 2 sine squared will make everything in terms of sines. So 1 minus 2 sine squared. Rewrite it. I'm going to negate it. And then from this point moving forward, it'll be the same again, right? That's a trinomial, that's factorable. We'd go from there. It's just like last night. Any questions on that? Number 9. Andrew's already got a creative solution, and so does Bailey. This is fantastic. Bailey, what were you going to say? Correct. So you're thinking get rid of that 2, and that's how you kind of came up with it. But anytime you see sine times cosine, you can always, you're not technically just inserting your own 2 to make 2 sine x cosine x, which should sound familiar to you. you're kind of multiplying both sides by 2, so that this side is now the sine of 2x. You go back to your double angle, and this side, a half times 2, just ends up being 1. Bailey kind of saw it differently. You saw it as clearing the 1/2, which then coincidentally made that happen. But also know that you can just make that happen on your own. You can just throw a 2 in there. You have to obviously do the same thing to both sides. So whether or not that was a 2, like if that was 1/3, multiplying by 3 on both sides, Bailey, what you saw wouldn't have been as helpful. So it's not so much about clearing that fraction, although that coincidentally would have worked here. It's more about insert that 2 so that you can use your 2 sine cosine. And then from here, this is, again, traditional from yesterday. We have a change in our period. So if x has to be between 0 and 2 pi, 2x has to be between 0 and 4 pi. So we're essentially going to go around our circle, not once, but twice, to find out where the sign is positive 1. Which, Connor, where's the first spot as you start progressing from 0 and going around the circle? Correct. What's the first angle we're going to come to that the sine will equal 1? Say it again. No, the sine of pi is 0. Pi over 2, correct. So 2x could equal pi over 2. What's the next angle we'll come to, Olivia? That has a sine of 1. When you come back around, correct. So 1 and negative 1 are tricky because the sine of this is 1. It doesn't have a second time in that first revolution because the sine of 3 pi over 2 would actually be negative 1, so you don't count that. So she's saying she knows it's when you come back around, but she doesn't know how to come up with that angle. There's 2 ways I'll give you. Number 1 is just add a full revolution onto this one. So if you know that's pi over 2, add on, what's a full revolution? 2 pi, so you could just do that. You'd have to get a common denominator and so forth, so that might be a little bit more labor intensive, but conceptually it's just a coterminal. Or if our denominator is pi over 2, this is 2 pi over 2. So this, a full circle is how many pi's over 2? 4 pi over 2, and then one more would be 5 pi over 2. And that's going to do it. Divide both sides by 2, so x will equal pi over 4, or x will equal 5 pi over 4. Are your 2 answers for x. Any questions? Jump to 10. Andrew. Squaring both sides is certainly an option, but you didn't square the binomial right. Because squaring both sides would make sine squared x minus 2 sine x cosine x plus cosine squared x. But I think that's also helpful, because what does that do for you? There's some formulas in there, 2, that you should be using. 2 formula sheet ideas, Olivia. Right? This plus this is 1. And what's this? What's 2 sine cosine? Sine of 2x. That part's a double angle. So then you solve. Subtract 1 from both sides. You get negative sine of 2x equals 0. You don't really need that negative there then because it equals 0. So that's negligible. And again, we do have a change of period. So if x had to be between 0 and 2 pi, 2x has to be between 0 and 4 pi. So again, we're going to go 2 revolutions around the circle. Bridget, so what is the first angle that has a sine of 0? 0, so 2x could equal 0. As we continue around the circle, what's the next angle we're going to get to, Trista? When sine equals 0. You missed one. Pi. So 2x could equal pi. Then 2x could equal 2 pi. And then 2x, there's one more. What is it? Nate. When does sine equal 0? So we said sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. What's the next one we're going to get to? Nope. 4 pi is not in our interval. That doesn't have an equal sign. 3 pi. And then when you solve each of those, x equals 0, x equals pi over 2, x equals pi, x equals 3 pi over 2. So there's something new that's an option. If you're at a loss, try squaring both sides. If 2 sides are equal and you square both of them, they should still be equal. So that's a legitimate, solving mechanism. And it happened to, not quite the way Andrew saw it in his head, but it happened to work out with a double angle and a Pythagorean identity. Good? Okay. And then lastly, this is going to be a calculator section just to review, because even though we don't have a calculator often, you do need to know how to find the angle measures when they're not going to work out nicely. So first of all, in the instructions it says round to 4 decimal places, x has to be between 0 and 2 pi. So what mode should your calculator be in? Radians. So that's first things first. And if it said between 0 and 360, then your calculator would be in degrees. So pay attention to that. And then what do I press to find what angle has a tangent of 12.8? Andrew? Second tangent of 12.84044. Now, before you hit enter, inverse tangent has a range of what to what? Going back. No, that's the range of tangent. Inverse tangent. When you take the inverse tangent of a number, it's always going to give you something between, Mackenzie? Right, so our calculator is going to give us an answer that's in one of these 2 quadrants only. Because our tangent is a positive 12, which one is it going to give us an answer in? What is it? First quadrant, correct. So I'm going to hit enter, and it's going to give me a number of radians that's in the first quadrant. Correct? Okay. So x equals 1.4929 radians. But we know that we're supposed to give every x value that works between 0 and 2 pi. They told us they wanted all the answers between 0 and 2 pi. So how many should there be where tangent is positive? How many times when you go around from 0 to 2 pi, how many times is tangent positive? Twice. Once in the first quadrant, that's what the calculator gave us. Because the calculator is always going to give us something between negative pi over 2 and pi over 2. Versus our question is actually asking us for all of the answers between 0 and 2 pi. So there's a little bit of additional thought that has to happen here. So if the first quadrant angle is 1.4929, what's the reference angle? Because we have to find the third quadrant's version of that. Andrew? But 180 is degrees. So that would be you, right, that would be you adding degrees to radians. So you didn't actually answer my question, though. You kind of are thinking of the final answer. My question for everybody else, and we'll do it your way as well, but what is the reference angle of this angle? How far away is this from the x-axis? 1.4929. That's kind of an easy question. When you have a first quadrant angle, that is its own reference angle. So that means when we go to the third quadrant, we need to go 1.4929 after pi. So there's pi, and you need to add on 1.4929. So your other angle is pi plus 1.4929, which is, in essence, Andrew, is what you said. I don't think you were thinking of it that way, but it does the same. You were thinking just add on a half circle, because that'll put it that way, right? That'll give you the opposite ray. Well, why did you say add pi onto it? Oh, so were you thinking visually of starting at 180 and then adding that reference on? Oh, okay, so then you were doing it the same way. But he mixed degrees and radians. That's why you don't add 180, you actually add pi. So if I just on my calculator do pi plus that answer, and then round 4 decimal places, 4.6344. So the thing you have to know about your calculator is for inverse tangent, it's only going to give you quadrants 1 or 4. If you do inverse sine, it's only going to give you quadrants 1 or 4. And if you do inverse cosine, it's only going to give you quadrant 1 or 2. You have to find out the other one on your own. Okie doke? Oh, I wish I had a different one here. Okay. So inverse cosine, on your calculator, it's only going to limit you to the first or second quadrant. Which one is it going to be? Second. It's going to give you the second quadrant version, but you're going to have another answer in which quadrant? The third. Does that make sense? That you have to find on your own. So this one, when I do inverse cosine of negative 0.4317, 2.017 is the angle. 2.0172. Sorry, 4 decimal places. So there's one answer. Now this one's a little bit trickier, because what is the reference angle? It's not 2 anymore. This one worked out nicely because the reference angle was the first quadrant angle. The reference angle here is that one, which is the difference between 2.0172 and what number is this? Pi. So to find your reference angle, we're going to do the difference between those, 1.1244. So to get the third quadrant's version of this angle that has a cosine that's negative, I need to start with pi, and I need to add that reference angle onto it. So x equals pi plus reference angle of 1.1244, which is 4.2660. That's a little trickier because we had to do some hidden work and find our own reference angle. Good. All right, and then 12. It looks like a typical factoring one, but I don't think it's factorable because you'd have to be sine of x and sine of x. 1 and 1, but one would have to be plus and one would have to be minus. So that's plus 1 sine x minus 1 sine x, which would be a 0 sine x in the middle. So that is not factorable. If something is not factorable, if a quadratic is not factorable, what do you do to solve it? Quadratic formula, right? So what is our a value? What is it? What's the coefficient of the first term? 1. B is -1. And C is -1. So the opposite of B is 1. Plus or minus the square root. B squared is 1. Minus 4A. C is -1. All over 2A is 2. That's going to give us 1 plus or minus the square root of 1 plus 4, which is 5, all over 2. Normally the quadratic formula says x equals. This is the sine of x equals because our variable is the sine of x. That's what's being squared. So if I do 1 plus the square root of 5 and divide it by 2, that's telling me that the sine of x equals 1.618033989. Or the sine of x equals 1 minus the square root of 5 divided by 2, negative 0.61803398887. One of those equations I'm completely going to cross out. Which one is it and why? Niche. Perfect. This has definitely no solutions. The sine of any angles always has to be between -1 and 1, and that's too big. So this is the only thing we have to solve. So there was a twist in this problem in and of itself because it was a quadratic formula, right? Now, here we're going to find another twist because when we do inverse sine, we're always going to get an answer between -pi/2 and pi/2. Because this sign is negative, it's going to give us the third quadrant version. So inverse sine of that negative 0.618 number, which I'm not rounding on my calculator, I just copied it down exactly from the step above. And it gives me negative 0.6662. Here's the second twist. Does anyone know what it is before I tell you? When they asked for our answers, they wanted all x answers that were between what? Andrew? And the problem would be? Right. This one's not even one of the answers that we're going to give, right? This gives us nothing but the reference angle. What is the reference angle? How far is that from the x-axis? How far is that? Right, 0.6662. So when we actually stick between being between 0 and 2 pi, we're looking for where sine is negative. So we are in quadrants 3 and 4 with a reference angle of 0.6662. So our third quadrant angle is going to be pi plus our reference angle. And our fourth quadrant angle is going to be 2 pi minus the reference angle. You always get to your angle by starting at pi or 0 or 2 pi and adding or subtracting the reference angle, whether you're going backwards or forwards around your revolution. So you would just type those into your calculator, and that would give you the two answers between 0 and 2 pi. So when sine and tangent are dangerous, because if you do inverse tangent or inverse sine and it's a negative number, it's going to give you a fourth quadrant answer that's actually lower than 0, which you have to then realize doesn't fit in the range of the answers that they're looking for. Does that make sense? Okay, so be careful of those. Cosine, you don't have that problem because it always gives you 1 and 2, and so you're already in that range that they want. So your homework for this one is right there on the bottom, 63 to 115. So kind of that next section where some of these substitutions actually